And then going to part B. In part B, the circle is x squared plus y squared minus 4x plus 6y minus 77 equals 0 at the point of tangency 5 and 6. So what must you know? You must know that this point given here is the point on the circumference of the circle where the tangent meets the circle. So for us to find the equation of the tangent, it means we need to first find the gradient of the circle at this point. And for us to find the gradient of the circle at this point, you need the gradient function of the circle at any point. So the key step here we do is to find the gradient function of circle, which is dy dx. That means we are going to differentiate the circle with respect to x. We shall have dx of the function or circle y squared minus 4x plus 6y minus 77 equals to, we also differentiate the right hand side with respect to x, 0. So we are coming to differentiate this. If we differentiate x squared with respect to x, it gives us 2x dx dx plus, how about if we differentiate y with respect to x, y squared gives us 2y, then dy dx. Remember, we are treating it as an implicit function. We are treating it as an implicit function. And then we shall now have minus 4 dx plus 6 dy dx. If we differentiate 77, we get 0. So we just equal to 0 when we differentiate that side. So this and this are going to cancel. This and this will cancel, giving us here 2x plus 2y dy dx minus 4 plus 6 dy dx equals 0. Let us make dy dx the subject of the formula. That means we shall have I will have 2y plus, I will have 2y dy dx plus 6 dy dx equals to 4 minus 2x. When we carry it to that side, when we carry this to that side. Therefore, when we factorize that, we shall have 2y plus 6 dy dx plus 6 dy dx equals to 4 minus 2x. What do we do here then? We make dy dx is 100. So dy dx becomes 4 minus 2x over 2y plus 6. So this is the gradient function of the circle at any point. This gives us the gradient of the circle on any point on the circumference. So at this point, so at the given point at 5 and 6, we can now get the gradient of the circle at that point. Therefore, we have dy dx at point 5 and 6 equals to, this is x, this is y. Substitute for them, then we shall have 4 minus 2 times x, which is 5, out of 2 times y, which is 6, plus 6. Then you solve that. It gives us negative 6 here. 4 minus 2 times 5, negative 6, 2 times 6, plus 6, 18, out of 18. This gives us a negative 1 out of 3. So this is the gradient of the circle at point 5 and 6. At the same time, that is the gradient of the tangent at the point 5 and 6. Therefore, the gradient of the tangent is negative 1 out of 3. Now, if you have the gradient, which we call m, Okay, and you have this point is also on that line of the tangent. So, and then you have 5 and 6 as a point. Then you can find the equation of the line, because the tangent is a line. So it is that you have a line with a gradient -1/3 and a point on it as 5 and 6. So you can just say from y was x plus c. This is the equation of the line. This is x, this is y. Substitute for them. That means 6 equals to m. M is the gradient, -1/3 times x, which is 5, plus c. Then you find c. 5 divided by 3 plus 6. So c is 23/3. After getting c, then you substitute for m and c here. Therefore, the equation becomes y equals to -1/3 x plus c, which is 23 out of also 3. That is method 1. Or you can use the method that I started with, that gradient n is given by changing y out of changing x. And we use the same points, which are 5 and 6. This is alternative. This is x1, this is y1. What is our m? This -1/3 equals to y2. Now we just write y minus y1 is 6 out of x2 is write x minus x1 is 5. Then you make y the subject of the formula. So we cross multiply, giving us a -x plus 5 equals to 3y minus 18. Let's make y the subject of the formula. So that here we shall have 3y equals to -x plus 23. Then we say both sides by 3, both sides by 3. Therefore, y becomes -x out of 3 plus 23 out of 3. The two answers are the same. This one is the same as -1 out of 3. Then we attach x plus 23 out of 3. So this is the equation of the tangent to the circle at the point 5 and 6.